let's talk about algebraic expressions.
Remember to have your notebook out and ready to go. You can always access the learning guide linked in the description below.
All right, we're gonna have you pause the video, start the lesson opener, and then come back, start the video, and check your answers.
Pause, we'll see you soon.
Okay, let's see how you did on the warm-up. A, associative property of addition, because what changed from one side to the other? The parentheses changed their association, what was inside. B, commutative property of multiplication. How did I know? 7 and B commuted, they move spots. So commutative property of multiplication. C, what's happened here? We have 9 times 1 equals 9. So what I started with, I end with. Identity property of multiplication. D, we have negative 11 plus 11 equals 0. So what's happened? I've added the opposite.
So we have inverse property of addition.
And last, how are you doing? We have distributive property, because what's happening from one side to the next? We are multiplying in, distributing that 3. 3 times x plus 3 times 4, 12. How'd you do? On to the lesson.
Okay, so today's lesson is all about algebraic expressions. So first we're just going to start with reviewing how to translate an English phrase into an algebraic expression. So let's take a look at these. A says 3 more than a number. We want to translate that into an algebraic expression. So we're taking words and making it math. So 3 more than a number. Well, more than, I'm adding, and a number. A number could mean, any variable you want. You could use x, you could use n. I'm going to use n for this one. So 3 plus n. All right, B says the product of a number and 7 increased by 11. Okay, so product is multiplication of a number, so we could make that n, we could make it x. This time I'll make it x, and 7. So I have x times 7. It makes more sense to write that as 7x. Comma, increased by 11. Increase, that's going to be adding, so I have 7x plus 11.
Let's take a look at C. 5 less than a number. Oh, that seems easy. 5 minus x, no big deal. Oh, wait a second, let me check that out. So 5 less than 10 would be 5, but 5 minus 10 is negative 5. Oh, I didn't do that right then. So 5 less than a number actually has to be where the 5 is behind it. So 5 less than a number, so x minus 5. Final answer, x minus 5. Next one, the difference of 17 and a number. This one we're happy about. Difference means subtraction, and we just go the order it says. So 17 minus n, no big deal.
Okay, let's try this last one, E. Let's see if we can get it right. 9 less than the quotient of a number and 2. Okay, less than. We just learned that means subtract from. So I'm going to subtract 9 from the quotient. Okay, remember quotient means division. So dividing a number and 2. So should I use x this time? So x divided by 2 minus 9. Did you get it right?
Wait a second! I did it already, and I put n divided by 2. Can I just use the divide by sign?
No, this is pre-AP Algebra 2.
Okay, you're right. So n divided by 2 using that fraction bar looks so much better, and it's the way that we encounter our equations now. So every time you see that fraction bar, we know that we're dividing by, okay? Let's look at F right now. We're still writing an algebraic expression, but we're presented with a situation. Marvin earns $10 per hour plus 3 cents per widget produced. So let's define variables. H equals the number of hours worked, and W equals the number of widgets produced. Therefore, Marvin's wage will be 10H plus 0.03W. Were any of you tempted to put an equal sign in there? Because I understand that, but we were asked to write an algebraic expression. You'll notice the next line says write an equation for his pay, the total pay. So now I'll write an equation. So P equals 10H plus 0.03W. I want us to start being more familiar with those two words, expression and equation. With an expression, we can simplify, we can evaluate. With an equation, we can solve. We never solve an expression.